Welcome back. In our previous video, we talked about why we want to carry out separation techniques. And the answer to the question is very simple. In reality, in nature, most things exist as mixtures, and we want pure substances. Because we want to leverage on the properties of pure substances. When they exist as mixtures, sometimes we cannot fully use the properties. So, the next question is, how do we tell if a substance is really pure? Because if I have seawater and salt water, honestly, if you just look at the two, they look almost the same, right? In fact, you cannot tell if something is seawater or plain water just visually. Of course, you could taste it, that's one way. But is there another way to find out if something is pure or not? We can find out if something is pure or not by looking at a property that all substances have: the boiling points and the melting points of substances. If a substance is pure, you'll find that it has fixed, or sometimes we say sharp, boiling points and melting points. If a liquid is pure, it will have a fixed boiling point. If a solid is pure, it will have a fixed melting point. So for example, pure water will have a boiling point of 100 degrees Celsius. This is fixed if it's pure. Pure ice, the solid form of water, will have a melting point of 0 degrees Celsius. And this is fixed if it's pure. Salt in its solid form will have a melting point of 801 degrees Celsius. And this is fixed if it's pure. That's one way we can tell, two ways we can tell if a substance is pure or not. And that being said, the flip scenario is this. If I have substances that are not pure, like let's say seawater, or seawater that's been frozen, the solid state, we'll find that they will melt and boil over a range of temperatures. A range of temperatures meaning that you won't find seawater boiling at 100 degrees Celsius. Instead, it will boil over a range. It may boil over a range of 100 degrees Celsius all the way to 110 degrees Celsius. It will boil over a range. Same for seawater, frozen seawater. What you expect of a pure ice cube, water ice cubes that melts at 0 degrees Celsius. However, if I have ice that's made up of seawater, you find that it melts over a range. It could melt from 0 degrees Celsius to, let's say, negative 22 degrees Celsius. And that's what I mean by it can melt or boil over a range. If something melts or boils over a range, it means that it is not pure. It means to say that it is a mixture. Then the question is, I would like to give you some examples of when this might come in useful. Some real life examples. You find in your textbook that your textbook talks about how impurities can affect melting points or boiling points. That means to say, let's say water is the substance I'm talking about, and let's say the salt is the impurity. Right? Your textbook has several blanks. They're asking you how impurities affect the boiling point and melting point of substances. Well, the more impurities I have in a liquid, it will actually increase the boiling point of the liquid. The more impurities I have in a solid, it will actually decrease the melting point of the solid. Okay, so I say again, the more impurities that are present in the liquid, the higher the boiling point. The higher the amount of impurities in a solid, the lower the melting point. I'll give you some examples of when this might come in useful. Let's say you are cooking, right? Let's say you want to cook pasta. Okay, put some pasta inside the pot. Let's say you want to cook pasta. The reality is that once your water hits 100 degrees Celsius, you have a problem. Your water begins to boil. And when it boils, the amount of water inside the pot will decrease. You slowly run out of water. That's a problem, right? If I slowly run out of water, I have to keep topping up so that I can cook my pasta. However, let's say I throw some salt in. When I throw some salt in, I'm adding impurities to the pure water. In doing so, I end up increasing the boiling point. That means to say, the water now may not boil at 100 degrees Celsius, it may instead boil at, let's say, 110 degrees Celsius. That means at 110 degrees Celsius, your water will not be boiling yet. And that means to say, you can keep the same amount of water inside your pot at a higher temperature without having to replace the water. And that may be even better because now your pasta can cook faster because of the temperature of the water is now much higher. It can increase up to 110 degrees Celsius without boiling away because the boiling point has been increased. I give you an example also of when decreasing the melting point of a solid may come in useful. In winter, many countries have a lot of ice frozen on the surface of their roads, surface of pavements. We all know that ice melts at 0 degrees Celsius. But what if I want the ice to melt faster? If I want it to melt faster, one thing I could do is decrease its melting point. If the melting point is lower, then it will melt faster. Imagine ice that melts at negative 22 degrees Celsius. Right? That means it's going to melt much faster. So in some countries, what they do is that they add salt to the surface of the ice. By adding more impurities to the ice, it helps to decrease the melting point of the ice, making it melt much faster. That way, people won't end up slipping and falling on the ice on the roads. Right? So thank you for tuning to this video. This video talks very simply about how do we tell if a substance is pure. We can tell if a substance is pure if it has a fixed boiling point or melting point. And if it's a mixture, you'll find that it has a range of boiling points and melting points. You also need to know how impurities affect the melting point and boiling point. If I have more impurities inside a liquid, it will increase the boiling point. If I have more impurities inside a solid, it will decrease the melting point. And I've given you some examples in real life of when this might be useful. In our next video, we're going to dive into some of the separation techniques that you can use to separate mixtures into pure substances. Thank you.